Now, as I mentioned, CIDR, or classless interdomain routing, was introduced in 1993, and CIDR replaces classful IP addresses. This allows us to use variable length subnet masks, or VLSM, and uses the notation 10.0.0.0/8 rather than the notation of 10.0.0.0/255.0.0.0. So for a Class A network, such as 10, this type of notation is used, and not this notation in CIDR. So firstly, I'm going to explain this notation of /8, and then I'll give you the reasons why the move was made to CIDR. So in CIDR notation, we use /x masks. So if we had a subnet of 255.255.255.0, that converts into 24 binary bits. So to work it out, convert the decimal octet to binary. So in the first octet, we have 255, which equals 8 binary ones. In the second octet, we have 255, which also equals 8 binary ones. In the third octet, we have 255, which equals another 8 binary ones. The last octet is decimal 0, so there are no binary ones in the last octet. So we've got 8 binary ones plus 8 binary ones, which equals 16, plus an additional 8 binary ones, which therefore equals 24 binary ones in the mask. So once again, if you count the binary ones, you end up with 24 binary ones. And therefore 255.255.255.0 can be written as /24 because there are 24 binary ones in the subnet mask. As another example, 255.255.0.0 is equivalent to /16. And why is that? Because 255 is 8 binary ones and 255 is an additional 8 binary ones, so 8 plus 8 equals 16. Hence /16 in the mask. So the /mask notation is essentially counting the number of binary ones in the mask. Masks have to be contiguous ones, as mentioned previously, so this is simply another way of writing the subnet mask. /16 is equivalent to 255.255.0.0. Now there are various advantages to using CIDR, and there is a reason why the industry moved to the CIDR notation. Now previously, before CIDR was used, we had class full address masks. So we had class A addresses, class B addresses, and class C addresses. A class A subnet supports about 16 million addresses and uses the mask 255.0.0.0. Class B networks support about 65,000 host addresses with a mask of 255.255.0.0. Class C networks support 254 host addresses and use a mask of 255.255.255.0. The problem with this method is what happens if a company wants to support 3,000 hosts, for example. So if the network had 3,000 hosts, which of these 3 address classes would the company get? Well, they could get a Class B address, but that's an awful waste of a lot of addresses. About 65,000 addresses are available in a Class B subnet. But in this example, the company only needs 3,000 host addresses. They could get multiple Class C networks, but that means that they're going to be allocated many Class C addresses, which has a negative effect on Internet routing tables. Now, rather than doing that, we can move the subnet mask in CIDR. Notice in Class A, B, and C addresses, the subnet mask is set on the octet boundary. Notice in Class A, B, and C addresses, the subnet mask is set on the octet boundary. Class A, first 8 bits. Class B, first 16 bits. Class C, first 24 bits. But rather than doing that, with CIDR, the subnet mask can be somewhere in the middle. It doesn't have to be on the octet boundary. So here's an example. We've got a subnet mask of 255.255.255.40. Notice the fourth octet is not set to 0, but to 240 in this example. So if we convert the decimal to binary, notice 255 is equal to 8 binary 1s, 255 is 8 binary 1s, 255 is 8 binary 1s, but 240 equates to 4 binary 1s followed by 4 binary 0s. Please refer to the binary videos if you're not sure how to convert decimal to binary. Now in this example, if you count the number of binary 1s, we have 8 binary 1s in the first octet, another 8 binary 1s in the second octet, therefore we have 16, another 8 binary 1s in the third octet, which equals 24, plus 4 additional binary 1s, which gives us a total of 28 binary 1s, or in other words, /28. So 255.255.255.240 equals /28. But notice in this example, the boundary between network and host is not on the octet boundary. Now remember, binary 1s indicate network and binary 0s indicate host in a network mask. So the boundary between network and host is no longer set on the octet boundary, it's been moved within an octet. Here's another example. In this example, we've got a subnet mask of 255.224.0.0. 255 in binary is 8 binary 1s, 224 is 3 binary 1s, followed by 5 binary 0s. So if we count the number of binary 1s, that gives us 11. So 255.224.0.0 is the same as /11. The network portion is on the left-hand side, the host portion is on the right-hand side. But notice once again that the divider between network and host is not on the octet boundary. It's somewhere within this octet. So in this example, the most significant 3 bits of that octet are network, and the remaining portion of the octet is host. Now in the subnetting videos, I'm going to show you this in a lot more detail. We're going to work out various types of subnetting. What I need you to understand with regards to CIDR at this point is that CIDR allows us to implement variable length subnet masks. No longer do we have class A, B, and C networks where class A is always /8, class B is always /16, and class C is always /24. When CIDR is used, the masks can vary, and that's what we use today. So from 1993, CIDR is more preferable than classful network masks. So going back to our example company that required 3,000 hosts. When using CIDR, it's not necessary to allocate a full Class B network to the company or allocate multiple Class C subnets. A subnet can be allocated based on the network requirements without wastage of IP addresses. So for example, a 172.16.0.0/28 subnet could be allocated to this customer. This subnet would allow for 4,094 hosts, which is still more than what was required in this example, but it's better than wasting about 62,000 IP addresses, which is what would have been wasted if a standard Class B address had been allocated. So CIDR, or classless interdomain routing, has reduced the depletion of IP version 4 addresses much better than what would have been possible if classful networks had been used. And for those reasons, classful networks of A, B, and C were replaced with CIDR in 1993. Now once again, in the subnetting videos, I'm going to discuss subnetting in a lot more detail. So please refer to those videos if you want to learn more about how to subnet a network or how to work out the maximum hosts that can be supported on a subnet, or which address is the first address or last address, or what is the broadcast address, and so forth for a specific subnet.